Hello, my cool kids and kittens. So, continue on with trig. So what's going to happen, I'm going to give you this note. And then next week, I'm going to give you a note on just trig. So plain trig, but I'm not going to tell you which one it is. Like, I'm not going to tell you if you have to use sine. I'm not going to tell you if you have to use cos and or tan. And then I'm also going to give you word problems. Same idea. I'm not going to tell you which ratio to use. Okay? So I'm just going to go through cos and tan. So a lot of this stuff is going to be very repetitive from the note that you just did. Okay? So lesson 18. Just because I want to get in your head. Okay? So some of the stuff's going to look very familiar because it's the very same idea. And yeah, so what we're going to do is go through some examples and we're laughing. Okay, so cosine and tangent. So earlier we did so. What does so stand for? S-O-H. Remember? So the S. Okay, I'll go a little bit. So the S is sine. And what does that mean? It's opposite over hypotenuse. Okay, so this is super duper important, and if you guys forgot that, please write it down so it's handy for you, especially when you do your assignment, and or go back and review the last note. If you guys aren't sure, 100% sure on that last note, go over it again, do the practice questions, guys, because you're gonna get this stuff. Okay, so SOH, so sine theta is equal to opposite over hypotenuse. Okay, so remember that this is the angle. Okay, so whatever the angle is, we would put it there, the angle in question. So we've done sine, we did examples on that one, so now we're going to go to ka. What is ka? Well, the C is cos. The A is adjacent. And the H is the hypotenuse. So, if you're going to write out the ratio, adjacent over hypotenuse. You see how the adjacent is listed first and it's on the top here? Okay, so even the order of that matters. So it's not C-H-A, it's not cha, it's ka. Okay, ka, like a bird. So C-A-H. Okay, then last but not least, toa. Like, oh my god, I hurt my toa. So again, the T is tan. Nice. Oh, another thing that people say is tan on arm. Tan on arm. Choop, choop, choop. Okay? Like I can make this thin and it goes thick. Oh, it's not there. We go. Okay, sorry, I'm just goofing off. Anyone got a tan on their arm? I got a bit of a tan on my arm. Got some funny tan lines happening too. But no, overall, nice and tanned. Okay, so T, tan. O, opposite. And then A, adjacent. So for these questions, especially too, I'm telling you I'm telling you that we're doing cos, and then I'm telling you we're doing tan. So you guys know which ratio to use. But as I said, next week, I'm going to get into a lesson where I don't tell you which one. So you guys have to determine that. So, yeah, we will be doing that. So just for now, I just want you guys to have the idea of how to do these, like how to label them properly and do the calculations. And then next week, we're going to do the like determining which one's which. Okay, so remember SOHCAHTOA. Okay, I'm gonna probably go say this a million times. So remember, we just labeled up here what SOHCAHTOA is. If you guys are bored, good, that means you know what you're doing. So Yeah, let's go. So cosine ratio can be used to find sine lengths and angles in right triangles. In a right triangle, the cosine ratio for each non-right angle is given by cos A is equal to adjacent over hypotenuse. I spelled that wrong. Look, I gotta fix that. So, in this example, the angle of question is my angle A. If this said cos B, or if this said cos C, that would be our angle of question. But because it says cos A, this is the angle of which we are looking at. So because this is our angle of angle of interest, we have to look at our adjacent. If my colors from the last note are different, I apologize. Couldn't remember which ones I used. So remember, adjacent, if you look at your note from last time, it's the one that touches the angle of interest. Okay, so it's this side here. You should already know that this is my hypotenuse. Okay, that should be second nature to you. That should just be like, boom, hypotenuse, where you at? There you are, because I know. Right? Yeah. Okay? So, hypotenuse, adjacent. So that means if we are looking for this angle, angle A, and we have this side, and we have this side, we can solve for that angle. Or if we have this angle and need this side, I can solve for this. Or if I have this angle and this side, I can solve for this. And yeah, I'm going to show you different examples. So just like last time, where can the cosine ratio be used? So we're going to do the same thing. Everything's in with respect to the determined angle, and we're going to see what we have. So remember, for cos, we need for cos, we need the adjacent and the hypotenuse. Okay? So, where can cosine be used? So I'm going to go like this. CAH. So can we use the cosine? So here's our angle of interest. We have the hypotenuse. Okay, that's there. That's good. We don't have an adjacent. We don't have this, meaning we can't use cos for this triangle if we wanted to solve for it. Let's go to the next one. Here's my hypotenuse. Do I have a letter or a number for my hypotenuse? I don't even have a hypotenuse, so I can't even use this. Let's go to the next one. Okay, so can I use my CAH? Here's my hypotenuse. That's what I need. What I use? There we go. Sorry, guys. Here's my green. There it is. Oh, I can use both of them. Perfect. So I can use cos to solve for this. Okay? So it depends on what we have. So, calculating ratio. So I'm going to pull out that calculator again. I should have had it up and ready. I do apologize. Online scientific calculator. What was the website that I used last time? I think it was this one. Beauty. So I'm going to continue using this one. If you guys want to use the exact one, perfect, because then at least you're following along and you know what you're doing, okay? So what's my question? My question is cos 74. So I'm literally going to type in cos 74. Please try this as well, guys, because if you don't, how are you going to know that you're putting it in your calculator right? And then you could get all your questions wrong on your assessment, and well, there you go. Then you're super sad, and then I'm going to have to wipe up all the tears, and I don't want to do that. So let's get her done, okay? Okay, so 0.2756, what did I say? To the nearest 4 decimal places. So one thing I didn't show you last time, I'll do it this time. So I'm going to write down this entire number. 0.27. You know what I'm going to do? I'm going to take a picture of it so I don't have to keep going back and forth. Click. So I've got 0.27563735558. Okay. So use your calculator to find each value to 4 decimal places, okay? So because this says 4, that means that's 4 numbers after the decimal. 1, 2, 3, 4. So that's here. So I'm gonna essentially get rid of the rest of those numbers. The one thing we do need to look at is we need to look at the number next to our last number and see if it rounds it up or rounds it down. Okay, this should be common sense to you guys by now. It's a 3, it makes it stay the same. So that means my answer for this is actually 2.756. Okay? Let's do it again. Cos 42. Cos 42. So 0. Oh, I lied to you. 743144825. It's 4 decimal places, so it's 1, 2, 3, 4. What's this number? It's a 4, so that would leave the 1. Technically, yeah, I'm not gonna get into that detail. So there we go. I can get rid of these now. Okay. So use your calculator to find the measure of each angle. So remember, we need to find the measure of A. So we're going to do our left side, right side. You don't necessarily need to do this, but still. We can't just simply divide by cos, because that doesn't work with respect to cosine. We need to do cos to the -1. Okay? So if we do cos to the -1, what you do to one side, you do to the other. That means this and this will cross out. So that means it's going to look like cos to the -1, 0.5736.